Hello and welcome back. This will be part 2 of our section on polynomials, section 4 of the prerequisites chapter. And let's quickly do another example of multiplying two polynomials. So again, and this is something we'll do essentially for the rest of this video, we want to distribute. And there's a lot of things to distribute here, so we have to be a little bit careful. But when we're multiplying two polynomials, I like to distribute the first polynomial across the second. So here what we can do is I will take the first term in the first polynomial and multiply it by the second. And I'll continue doing this for each term. So the next term is going to be 3x, and I'll multiply it by the second polynomial. And then I'll take the third term and multiply this by each, remembering that this is going to be a negative 7, so I'm going to subtract 7 times the second polynomial. Again, now we have a little bit more to distribute. Now I have to distribute the x to the fourth to the x squared and the 2. So x to the fourth times x squared will be x to the sixth power. X to the fourth times 2 will be 2x to the fourth. Next, 3x times x squared, the 3 sticks around, and then the x times x squared, those will combine together to give x to the third power. Likewise, 3x times 2 will be 6x. Lastly, negative 7 times x squared will have a negative number, so this will be negative 7 times x squared. And then lastly, negative 7 times 2 will be negative 14. Now, this is not in order, and it doesn't have to be, but I think that reading polynomials is easier when the terms are listed in order of decreasing degree. So the degree of the first term, the largest degree here will be 6. There are no 5s, but there is a 4, x to the fourth power. We have an x to the third power. We have an x to the second power, remembering the negative sign out front. We have an x to the first power, and a constant term. And what you'll notice is that there are no like terms, so there is no more simplifying to be done. So again, just lots and lots of distribution here. And what we'll do is we'll specifically look at binomials for the rest of this video. Binomial is when a polynomial has exactly two terms, like the first polynomial here and the second polynomial here that we are multiplying. So let's multiply this. Again, I'll take the first term in the first polynomial and multiply that by the second polynomial. And I'll take the second term, which is going to be 2, and I'll multiply that times both terms over here. And again, I will distribute, so the 3x times the 4x. The 3 times 4 is going to be 12. X times x is x squared. Also 3x times the 5, so this will be 15x. Plus 2 times the 4x will be 8x. Plus 2 times 5 is 10. Now I want to stop and pause for a moment. I haven't simplified this. I would have to combine the like terms in the middle. But I want to point out that there's a pattern going on here. When we look at this term here, this 12x squared, where did this come from? This came from multiplying the 3x and the 4x, which happened to be the first terms in both polynomials. Next, we had the 15x, which came from multiplying the 3x and the 5. The 3x and the 5 are the two outside terms in the polynomials, the ones furthest away from the middle. Next, we had 8x, which came from 2 and 4x, and these came from the inner two terms in the polynomial. And lastly, the 10 came from multiplying the 2 and the 5, which are going to be both of the last terms in the polynomial. And this acronym, F.O.I.L, first, outer, inner, last, is very helpful when multiplying two binomials together. It only applies when you're multiplying binomials, before we had multiplied things that aren't just binomials. This has 3 terms in it, so it's a trinomial. But in the special case when we're multiplying binomials, we have this clever formula here. So again, here's just a general polynomial with 2 general binomials that we were multiplying together. So let's multiply the first 2 terms, so ax and cx. Next, we'll multiply the outside terms, the outer terms, which is going to be ax and d. Next, we'll multiply the inner terms, the 2 inside terms, which is going to be b times cx, and then the last terms. So the last 2 terms are b and d. So again, it's just this pattern. It's multiplying the first terms in the binomials, then the outer terms in the binomials, the inner terms in the binomials, and then the last terms in the binomials. And this is just a pattern to help us go a little bit quicker when we're multiplying. So we can use this pattern to help us in some specific situations. It could be that our polynomial isn't our 2 binomials that we're multiplying together are nearly the same, except one has a plus sign in the middle and the other is actually being subtracted. You might recognize this from before. A sum of 2 terms and a difference of 2 terms, these are called conjugates. And these are what we used when we were rationalizing the bottom of a fraction. If we had a square root appear in a sum below, we can multiply by the conjugate, and this is just the same as multiplying by the conjugate. So what happens? We need to multiply the first 2 terms. Those are both a, so we get an a squared. Now we multiply the outer terms, a times a negative b. So we have minus ab. The inner 2 terms, which are just another a and a b. And then the last 2 terms, a b times a minus b. So this is going to be minus b squared. But what you'll notice is that the inner 2 terms cancel. So altogether, this is just a squared minus b squared. So when we're multiplying the sum and difference of 2 terms, there's a very simple formula. And you can either multiply it all out by hand, or you can remember the formula, whichever way works for you. So for instance, 4x plus 3 times 4x minus 3, we know that we're just going to square this first term, and we'll subtract the square of the second term. When we simplify this, 4x squared, so the 4 squared is 16, and the x squared is just x squared, minus 9. It's pretty simple. Saves a lot of steps. Here, I've done the subtraction term first, before, the subtraction binomial first before the addition one, but it doesn't matter because the order in which we multiply numbers, say this number and this number, doesn't matter. So again, I will square that first term, and then I will subtract the square of the second term. And again, we can simplify this. 2x cubed squared, 2 squared is 2, and x cubed squared will be x to the 6th power. And then likewise, we'll have 1 squared, and 1 times 1 is just 1. Okay, so that's multiplying the sum and difference of 2 terms, so conjugates. We could just multiply 2 binomials that are exactly the same and have a plus sign in the middle. So again, if I write this out, this will be a plus b times a plus b. Okay, then I can use FOIL. So the first 2 terms times each other, the outer terms, the inner terms, and then the last terms. And what you'll notice is that AB and AB are actually the same thing. So I can combine these like terms, say that it'll be a squared plus 2 times a times b plus the last b squared. So again, I can use this formula. It's fairly straightforward. X plus 5 squared. I will square the first term. I'll end up squaring the last term. And I'll take 2 times the product of the terms in the middle. So it'll be 2 times x times 5. So if I simplify this, this will be x squared plus 2 times x times 5 is 10x plus 25. Again, let's do a little bit trickier one. We've got x cubed plus x. So I want to use my formula. So we'll take the first term and we'll square it. So x cubed squared. Take plus 2 times the first term times the second plus the last term squared. So again, simplifying, x cubed squared is x to the 6th power. 2 times x cubed times x is x to the 4th power, and x squared is just x squared. So having this handy formula memorized will be useful, but certainly not necessary. We could just do all of this by distributing lots. And then the last thing that we'll look at is, again, what happens if we square a binomial that is subtraction instead of addition in the middle. So this will be a minus b times a minus b. FOIL, so first a squared. Outer a times negative b. Inner negative b times a. And last, negative b times negative b. Again, the negative signs will cancel out here, but now I have a minus ab. Those are like terms and will combine. And then the last term. Okay, let's use our formula. We've got a squared minus 2 times the product of the two parts plus the last squared. So here I have 3x squared. I will take minus 2 times the first term times the last term plus the last term squared. And again, we can simplify. 3x squared will be 9 times x squared. Here I have minus 2 times 3x times 2. So I have one minus sign, that won't go away. But 2 times 3 times 2. 2 times 3 is 6, times 2 is 12. Plus 1x hanging around. Plus 2 squared, which is 4. Lastly, we've got this, which will be, I'll take the first term and I will square it according to our formula. And we're subtracting, so subtract 2 times an x squared times a 7x plus the last term squared. So we continue, so x squared squared is going to be x to the 4th power. We'll have minus 2 times x squared times 7x. So we'll have minus 14 times, so we've got an x squared and an x, so this is x cubed, plus 7x squared, so 7 squared is 49, and x squared is x squared. So I will stop there, and I'll continue in the next video, still looking at multiplying and adding polynomials.